Hi guys, so in this video we're going to use the steps from our first introduction video on the AC method to go through our first example. Here's just a quick review of the steps. If you'd like to hear them in greater detail, please go back and watch the introduction video. This is just here so you can pause it, read the steps, refresh your brain, and we'll jump right into our example. Okay, so now let's look at an example of how we actually do this step by step, so it'll make a lot more sense when you actually see it done out and see the math. So this is our first example, okay? The directions would say something to the effect of factor or fully factor, and then it would give you a trinomial. So here we have factor x squared plus 6x plus 8. Now the very first thing that I am thinking is, okay, these directions are telling me I need to factor. So that means that my answer better be in the form of factor times factor. And guys, I literally tell my students, write that on your paper. Make sure that you know what the directions mean. That is a huge part of understanding math, okay? So write that next to the directions, right? Okay, factor times factor. So that way when you get to your answer, you go back and you make sure that your answer is in this form, factor times factor, okay? So remember, when you're factoring, the first question you should always ask yourself is there an overall GCF? And if there is, you should factor it out. So I'm looking at this trinomial, x squared plus 6x plus 8, and the first thing I look at is the coefficients. My coefficients are 1, 6, and 8. Do they share any factors? Well, no. Aside from 1, they don't. Okay? And then I look at my variable terms. I have x squared, x, and then my last term doesn't even have a variable in it. So they don't share a common coefficient. They don't share a common variable. So there's literally nothing I can pull out here. My GCF is just 1. Okay, so there's no overall GCF I can pull out of this, which means I can now move into my next step, which is count the number of terms. Okay, so when you're asked to factor, the first thing you want to do is check for an overall GCF, and the second thing you want to do is count the number of terms. I have 1, 2, 3 terms, which means we're going to be using the AC method, okay? If I had had 4 terms, I'd be using factor by grouping, but I have 3 terms. That tells me I need to use the AC method, all right? So the first step of the AC method is to label your coefficients A, B, and C. So what I've done is I've sort of rewritten my trinomial over here, okay? And I wanted to sort of highlight those coefficients so you could see them a little bit better visually. So my A here is actually this invisible 1, right? I didn't have a coefficient in front of my x squared term. Whenever I just have an x squared or a y squared or an x or a y with no number in front of it, there's just this invisible 1, right? Because 1 times x squared is x squared. So my A here is 1, all right? What's my B? It's 6, and my C is 8. So remember, those A, B, and C, they just stand for the coefficients, okay, of your terms, right? And your trinomial should always be written in descending order. If it's not, you should rearrange it so you don't mix up those A, B, and C's. Like if this had been 6x plus x squared plus 8, well, it's the same trinomial, but you'll notice that it's not in descending order, right? So you would have to rewrite it as x squared plus 6x plus 8 so that you label your A, B, and C correctly, because otherwise you would label it like this, A, B, and C, and your A would be 6, your B would be 1, and your C would be 8, and the AC method wouldn't work, okay? Your A, B, and C are the coefficients in front of your variables when it is written in descending order, okay? Highest degree to lowest degree. So that's important. So make sure if you need to, you rearrange your polynomial so that it is in descending order. But this one is given to us in descending order, so we can just label our A, B, and C pretty quickly. Now we need to multiply A times C, so let's do that, okay? Our A was 1, our C was 8, so 1 times 8 equals 8, okay? That's the first step. You multiply A times C. We need to find two factors of A times C that add to B. So let's take a look at that. When I do this step, you guys, I always draw a table. And on one side I put multiply, and I put my A times C. And on the other side I put add, and I put my B, okay? Because we are trying to find two factors of A times C that adds to B. Well, what is A times C? It's 8. We already figured that out. What's my B? It's 6. So we want two factors of 8 that add to 6, okay? So now I'm going to start on the left side of my table, and I'm going to list all the factors of 8. And I always just start with 1, you guys, okay? So 8 divided by 1, right? Well, that gives me 8. So my first pair of factors is going to be 1 and 8, because 1 times 8 is 8. Okay, and then I move to 2. Can we divide 8 by 2 evenly? Well, we can, right? 8 divided by 2 is 4. So my next pair of factors is going to be 2 and 4. And then I'd move to 3. Does 8 divide by 3? No, it doesn't. Does 8 divide by 4? It does, right? 8 divided by 4 is 2, but we already have that pairing, so we can stop, all right? Those are all the factors of 8. So remember, I'm looking for factors of A times C, so factors of 8, that add to B, that add to 6. So now I'm going to move over, once I have all my factors, I can move over to the right side of my table where it says add, okay? So now I'm going to check each pair of factors to see if they add to 6. You might see it already, that's fine, okay? But we're going to do it all out the first time so you guys can see the example. So now I'm going to add together 1 plus 8, that equals 9, okay? So remember, I want it to add to 6. Does that add to 6? Well, no, it doesn't. So that pair of factors does not work. Let's try 2 and 4. 2 plus 4 is 6. Does that add to 6? Sure does. So this is the pair of factors that I wanted, okay? 2 and 4 are the pair of factors that I'm going to use in my next step. So now that I have those two factors, I'm going to replace the B term with those factors, okay? Which should sort of make sense, right? I wanted two factors of 8 that added to 6. Why? So I could replace that 6 with those two factors. So now I'm just taking my original polynomial, my original trinomial, and I'm rewriting it so that I'm replacing that 6 with the 2 and the 4 that I just found, okay? That's where that came from, because it's equivalent, you guys, right? 2x plus 4x, what does that equal? It equals 6x. So these are still equal. This polynomial and this polynomial are completely equivalent. X squared plus 6x plus 8 is the same thing as x squared plus 2x plus 4x plus 8, because 2x plus 4x is 6x, right? This is exactly the same, all right? So we're mathematically sound right now, okay? We haven't changed this in any way, but this is going to make it a lot easier for us to finish this factorization, because now I have 4 terms, okay? And I know that when I have a 4-term polynomial and I'm factoring, I use factor by grouping. So now we're going to use factor by grouping to finish this factorization, okay? So I obviously don't have enough room on this side to do that, so we're going to move on to the next slide so that you guys can see how to finish this off. All right, so let's move on down the slide. Okay, so now we've taken our two factors, 2 and 4. We've replaced our B term, our 6, with those two factors, right? Okay, so now you do factor by grouping to finish this factorization. And how do we do factor by grouping? When we split that polynomial right down the middle, so we have two terms on the right side, 2 terms on the left side, and we finish that factorization. So let's start with the left side. Okay, well, when we just look at the left side, okay, and we just sort of block this out for now. We'll deal with that in a minute. All I care about right now is the left side. X squared plus 2x. Well, now I'm going to factor that left side. So I ask myself, is there a GCF? Well, yes, there is, right? Both of these terms share x, okay? Did they have a common coefficient? No, because the coefficient here was 1 and the coefficient here was, of course, 2, all right? So they don't share any factors, but when we looked at the variable, we saw this x squared and this x. Remember, you always take the smallest of those, okay? they both share an x. So our GCF is now x. Okay, so now we're going to, of course, factor that x out of both terms. And when we do that, just factor it out just means divide by it, right? So now when we do x squared divided by x, we have 2 copies of x, we're dividing and taking one out. That just leaves us with an x on this side. And of course, these x's cancel completely, which leaves us with a 2 on in the other term. So when this factors, it factors as x times x plus 2. All right? So that's where that comes from. Right? We always have to remember to include that GCF in your factorization. Don't forget that. Okay? All right, so that was the left side. Now, let's talk about the right side. So we're going to block the left side out, and now we're going to factor this side. So let's factor the right side, 4x plus 8. The first thing you're going to ask yourself, is there a GCF? If we look at the coefficients this time, 4 and 8, they do share a factor, right? They both can share the factor of 4. And then we look at the variables. Well, only the first term has a variable. The second term does not, so they do not share a variable in the GCF. Okay, so our GCF here is just 4. Then again, we need to factor that out. That just means divide, right? So we divide both of these terms by 4. 4 divided by 4, the 4's are going to cancel, leaves us with an x. 8 divided by 4 is going to leave us with a 2. So that leaves us with 4 times x plus 2. That's how the right side will factor, right? You can never forget your GCF when you're factoring. And then, of course, here's our x plus 2, and that's where that came from. Okay, so now that we've factored both sides, we can finish off our factor by grouping. That gives us this new almost completed factorization. We have x times x plus 2 plus 4 times x plus 2. We can look at that and say, oh my goodness, now is there a GCF that we can pull out of this? Well, there sure is, because both of those terms share x plus 2. So our new GCF is x plus 2. When we factor that out, remember, from both sides, remember factor out just means divide. So let's divide both these terms by x plus 2. They cancel, and that leaves us with x plus 4 over here, right? All right, so that gives us a factorization of x plus 2, we can't forget that, and then of course x plus 4 when we factored everything out. All right, so that is the AC method. Now guys, I know that seems like a lot of steps the first time you watch it through. Trust me, the more you do this, the faster it will become. So we will do one more example together. I'm going to go a little bit faster through the next example, and then you guys can try some on your own, all right? Here are a few examples for you guys to try on your own, okay? What I highly recommend doing is to go back to the beginning of the video and take each of these problems, write them on a separate page, and as I go through a step of the AC method, pause the video, and then you do that step for each of these problems, right? If you're still feeling a little bit uncomfortable with using the AC method to factor, I do have a video that shows you a second example of how to factor using the AC method. It will be right below this one. So if you're not quite comfortable yet, definitely take a look. And in that video, I have a leading coefficient that is not 1. So if you want to see an example of that, take a look at the next video.